Okay, we're here to talk about inequalities. And you've probably seen inequalities before, so I'm going to try and make it fairly quick. So, first off, we're going to talk about what is the difference between an equation and an inequality. And you can see it kind of in the name here. An equation is when we have two things that are equal. So, like 2 equals 2 or x equals 2. Something like that, where I say this is the same as that. Equation as an equal, right? And inequality, you can see that in the name as well, right? Unequal, as in when things are not equal. So you could say that 2 is not equal to 3, or you could say that 2 is less than 3, or you could say that 2 is less than or equal to 3, because it is less than. You could say that 3 is less than or equal to 3, because it is equal to. So an inequality is just comparing those two things, rather than an equation is saying these two things are the same. This is comparing them, saying like one is less than or one is greater than, or it's just straight up not equal. So there are the definitions for you there. Real quick, you probably want to write those down in your notes. You can pause the video here. I'm going to move on. So the signs, we've got greater than or equal to, and then less than or equal to, or just straight up not equal to. So we know that the mouth of this guy, the bigger side is going to open to the bigger number. So 5 and 2, like if we're comparing these, we know that the larger side goes towards the larger number. It's saying that start big, get smaller to get to 2. This is how you can think of it. Some people like to think of it as like the fish is, or the alligator or whatever is eating the bigger number because he wants the bigger meal. It's another easy way to think about it. We know that this guy means equal to because it's just the equal sign, except it's taken that top bar and made it an inequality sign, right? It's the same thing. It's just got that equal sign. The top part is now a less than. This means less than or equal to. So the biggest difference between these two things is where their solutions are. We know that a solution is something that makes the statement true. So if I were to say x is less than 2, in order for this to be true, any solution would have to be less than 2. So 1 is a solution, 0 is a solution, 1.9 is a solution. Anything that makes this true is a solution. So versus an equation, this has 1, right? 2. X has to be 2 in order for this to be true. 2 equals 2. That's it. There's nothing else. I can't say 1 equals 2 because it doesn't. There's only one solution here. If we have x equals 2, there's 1. All right. Versus this over here, we've got a whole set of solutions here. We've got a solution set for this inequality where there's infinite solutions over here. So like we said, 1.901, -10, -10 million, right? I mean, there's infinite solutions. Now, infinite solutions doesn't mean that every solution, everything's a solution, right? Because 3 is not a solution, because 3 is not less than 2. It just means that there are infinite things that are less than 2 that I could count as a solution here. So that's the biggest difference. The equation, it has to be equal to this. So we've got that one solution that's right. In inequality, we've got this whole solution set, right? So if we wanted to graph a solution like this, we usually do it on a number line. The important thing about a number line, just have it going. Make sure you have 0 on there, and then you can put the other numbers wherever you want. If x is equal to 2, not wherever you want, how they compare to 0, right? Positives go over here, negatives go over here. If it's equal to 2, you would just put, I've got a dot on 2. That's my solution, right? But what if I said that x is less than 2? Make that number line, put 0 on there, put 2 on there, And in order to make this is what we call a strict inequality. They're strict when they're not allowed to be equal to. So I would say that it's an open dot instead of a filled in dot, because that allows me to be equal to. And then the whole set is all this over here. You color in this side basically and say that this is all the solutions. Anything that's less than 2 works, right? Because we had our 1.9, we had our 0, our 1, our -10. Whatever over here is a solution to this. So that's why you would graph it like that. If it had said x is less than or equal to 2, the only difference is you would have to fill that in. So make 0, 2. Since it's allowed to be equal to, that dot's filled in, just like here, right? A filled in dot, and then color that way. Okay, so you're going to see these in multiple ways. I'm going to show you each way that they would show up. So just we got a greater than example here. So I'm going to put 0 here. I'm going to put 5 here. It's strict. It's not allowed to be equal to. So, and then it's going to be all the numbers that are greater than, right? Away from 0, 6, 7, 8, a million, whatever. Anything that's greater than 5 works. If you see something like this where 2 is less than x, which is less than or equal to 5, we've got something else going on here. So let's put the important numbers up. 0, 2, and 5. 2 is less than x, which means x is greater than. You can see x is on the greater than side. X is greater than 2, and it's strict. So I have to have an open circle here, and it needs to go this direction, right? But it also says that x is less than or equal to 5. So it's allowed to be equal to, so I can fill in 5, and less than, so it needs to go this way. So you can see that the actual solution set is right here in between. It's allowed to be 5 and less than, but it has to be greater than 2. So it's all these in between, 2.5, 3, 4, 4.1, whatever, right? Everything that's in between here, it's a whole solution set. Even though this arrow doesn't go on forever, there's technically still infinite solutions here, because you could go to 4.1, 4.2, 4.6758 to 4.892 to however far you want to go. There's infinite numbers in between any two numbers, so there's still infinite solutions here. The last way you'll see it, let's make this negative. Last way you'll see it is to, oh, that's a -2. Is like this, where it says or. So I have x is less than or equal to -2. So it's allowed to be equal to. I'll fill it in, and less than. And this one greater than 5, not allowed to be equal to. So it's open, and then greater than. So you can see it's counting pretty much anything that's greater than 5 and anything that's less than or equal to 2. And these things don't count in between here. So that's how you're going to see it when you're graphing.